सबको स्क्रीन दिख रही है?
Yes, ma'am.
ठीक है. So, as of now, what we saw in CNN was कि uh, we learned what convolutional neural networks are, and then we saw some projects उस पे. Now there are few more concepts. Concepts like transfer learning, concepts like data augmentation, and I have one project as well that I can give you a demo. And then why do we implement dropout? So कुछ छोटे छोटे चीजें हैं. So it will, I don't think it will take more than an hour for today's class, and we'll wrap up CNN इस class में. So we'll start with the first concept, that is transfer learning. So किसी ने भी इस term को सुना है, or you have any idea about what this term means? ये आप unmute करके बोल सकते हो. Yes, अंशिका.
I'm using pre-trained model that
Hmm.
are trained on some other weights to train your own model specifically for your data set. It actually increases the metrics and precision of the model.
Okay, kind of correct. Good. That
It
you.
reduces the training time of the also model.
हाँ. तो एक एग्जाम्पल लेते हैं. तो लेट्स से आपने डिसाइड किया कि आपको आर्टिफिशियल इंटेलिजेंस सीखना है. ठीक है. So one way is that you search online some books, you download some PDFs, and then you start learning everything, machine learning, deep learning, AI, on your own. ठीक है. Second is that maybe you get a teacher for yourself. Like right now, I am teaching you. So you have a teacher who is teaching you those concepts जिसको already ये सारी चीजें पता है. So which one do you think is more beneficial for you as a student to learn? खुद से book पढ़ना?
Having a teacher.
Yes, having a teacher. So that is transfer learning. So let's say if I'm working on any problem, ठीक है, कोई भी problem है. So let's say that this is a task. I'm working on some task. Task is to detect pedestrians in night time. ठीक है. Now I can start. What I can do is I can have all the images. I can get lot of images. Daytime में कैसे pedestrians की images हैं, night time में कैसे हैं. And then I can try building a model from scratch जो टाइम कंज्यूमिंग होगा. एंड देन एक और चीज है, लाइक इफ यू आर बिल्डिंग एनी डीप लर्निंग मॉडल्स, हमें डेटा बहुत ज्यादा चाहिए होता है, देन ओनली दे परफॉर्म गुड. सो वी नीड लॉट ऑफ इमेजेस एज वेल. So that is the traditional way of working. What transfer learning allows me to do is, let's say if I already have an existing model और मैं उस मॉडल को यूज करती हूँ. So I have a model. I uh, freeze the layers of those models, and then I will add one or two layers of mine, and मैं उसको अपने data set पे use करूँगी. Now this model that I'm using, that pre-trained model, a good thing about all these pre-trained models is that these models are trained on vast amounts of data. बहुत सारे data पे train होते हैं. तो there can be two cases, like आपका जो task है, first of all you are getting a trained model, so obviously it will be very less time consuming. आप सिर्फ एक दो कुछ अपने task के हिसाब से layers add कर रहे हो, and then you are actually using it for your own task. Second is that हो सकता है आपके पास उतना data भी ना हो. तो जब आपके पास डेटा नहीं है उतना ज़्यादा, तो यू डोंट नीड टू कलेक्ट मोर डेटा बिकॉज वो मॉडल ऑलरेडी बहुत ज़्यादा डेटा पे ट्रेन्ड है. सो दीज आर लाइक द काइंड ऑफ बेनिफिट्स ऑफ ट्रांसफर लर्निंग. So this is an example where, let's say I have a task to detect pedestrians in daytime, pedestrians in nighttime. So I can build two separate models for them, and it will be time consuming. Second is I have a task A that is to detect pedestrian in daytime. I have a model. I use the knowledge from these models जो भी initial weights हैं, जो middle layers I just freeze them, and then I add one or two layers of mine, and then I train the model on this task, detecting pedestrians in nighttime images. So I'll be able to do it much faster. I'm using the existing pre-trained model जो इस task के लिए था, for this different task as well, for task B as well. Now one important thing about transfer learning is these tasks should be similar. If they are not similar, then using transfer learning can give you bad results. So, for example, इस case में these tasks are similar, like detecting pedestrians in daytime, detecting pedestrians in nighttime. Can you tell me what can be the disadvantage of using transfer learning? मतलब obviously it is helpful, but then there is a condition कि the tasks should be similar. वरना फिर वो अच्छे रिजल्ट की जगह खराब रिजल्ट देने लगता है. Can you tell me some disadvantage?
मैम बहुत सारा
मैम
सिमिलर डेटा
इसमें
हो जाएगा।
ओवरफिटिंग की प्रॉब्लम हो सकती है।
ओके, और कोई और भी बोल रहा था?
मैम सिमिलर डेटा बहुत सारा हो सकता है।
नहीं, ये प्रॉब्लम नहीं हुआ. डेटा ज्यादा होना तो अच्छा ही होता है हमेशा. So I used one term कि task, similar task पे transfer learning apply करना है. How do we define this similarity? So there is no definite way of defining how similar is this task to the like, can I use this model for my task? Is my task similar as the model जो model था जिस task के लिए pre train किया गया था? मेरा task उससे similar है कि नहीं, वो मैं define कैसे करूं? So there is no global standard या universal way उसके लिए. So for this, like, we need to keep in mind that whenever we are using these pre-trained models, we use those specific models जो मेरे tasks से align करते हो. And a lot of time it is very difficult to measure कि कितना similar task है. Secondly, as I told, it's not always effective. तो कभी कभी, like, at sometimes it may not give good results as well. And जब आप ये इट्स नॉट अ कंप्लीट सॉल्यूशन, लाइक ऐसा नहीं होता कि आपको डेटा प्री प्रोसेसिंग नहीं करना पड़ेगा इफ यू आर यूजिंग ट्रांसफर लर्निंग. सो जो इनिशियल स्टेप्स है ना आपके, लाइक यू नीड टू डू डेटा क्लीनिंग, डेटा प्री प्रोसेसिंग, देन यू यूज अ प्री ट्रेन्ड मॉडल ऑन टॉप ऑफ योर डेटा. सो इट इज not replacing that entire process, it is just that you get एक मॉडल जिसको आप फ्रीज करके and then you can add in some layers of yours or you can use it for your own task. This is transfer learning. The merit demerits लिखे हुए हैं. I'll share the slides, आप लोग पढ़ लेना, but overall मैंने बता दिया है. Advantages, of course, like we can work with small data set, it reduces overfitting, performs well with limited data as well. Um, gen Again, like, since it is using a pre-trained model, उसको हम fine tune भी कर सकते हैं, these transfer learning वाला part. So there is okay, there are two more terms, pre-training and fine-tuning. किसी को पता है pre-training का मतलब क्या होता है? Pre-training and fine-tuning. Can you try to answer what these terms mean?
मैम फाइन ट्यूनिंग का मतलब तो
And
होता
the
है जैसे जो हमारा ट्रेंड
fine
मॉडल है
Hmm.
उसको हम लोग और ज्यादा उस पे ट्रेन करते हैं। मतलब और वेट्स पे या एग्जैक्टली मैम नहीं याद आ रहा है
ठीक है, but you
लेकिन
are in the right direction. तो सही बोला आपने, थोड़ा थोड़ा. बाकी और कोई आंसर करेगा? ठीक है. So pre-training वो वाला process होता है, basically we have got some data and an untrained model and then हमने उसको train कर दिया. So like that phase is called as pre-training, training my model on the data. Now what is fine-tuning? Now these models, for example, there is a model by, okay, LLMs का, so there is one such LLM called as Falcon by Google. ठीक है. It is used for same, like text summarization हो गया, question answering हो गया, जैसे चैट जीपीटी है वैसा ये कि LLM मॉडल है. बट देन इसका एक और वर्जन है which is called as Falcon Instruct, which is a fine tuned model. So what is different? ये एक model है that is trained for some specific tasks. So let's say it is trained for some n number of tasks. And n number of tasks में it can be summarization, question answering, like there can be multiple sentiment analysis, ऐसे कुछ tasks हो सकते हैं, different categories of task. This Falcon Instruct model is trained for one more task, or you can say इट एक्चुअली एक्सपेक्ट्स कि जो यूजर है वो इंस्ट्रक्शन मुझे दे. So it takes it instruction based prompts and it is trained for some different set of tasks. Like ये एक general set of tasks के लिए trained है. This is some specific set of tasks के लिए trained है. So this model is designed in such a way कि अगर उसको instruction based prompts मिलते हैं then it is going to give you good results. तो बहुत बहुत बारी हमें chatbots ऐसे चाहिए होते हैं जहाँ पे users is giving some instruction and it should actually just answer whatever instructions it has been told to. Like ChatGPT या Gemini में आपने देखा होगा when you ask something वो बहुत सारा out of the box data भी दे देता है that is not relevant to you या फिर जो आपने नहीं पूछा होता है. So that is the generalized way of answering. It is not task specific. These are very general models for huge variety of tasks. Um, एक ये चीज है. So when I talk about fine tuning, what I do is I already have a pre-trained model, and then I try to uh, adapt this model for a task specific scenario. So if I want to, uh, let's say I know English language, but then I don't know how to write research papers now, or let's say writing some formal, academic things. So उसके लिए मुझे क्या करना पड़ेगा? There is a certain way of writing research papers. मतलब आपको format define करना होता है. There are some certain sections that you need to define. Then you don't use your Google Doc editors for it. You probably go to Overly for LaTeX to document your um, research paper. So this is fine tuning. Fine tuning में हम हमारे मॉडल को क्या करते हैं? जो मेरा existing मॉडल है, I try to add in more layers and then I train it for a specific task. So let's say ChatGPT is a generalized model. अगर मैं फाइनेंस बेस्ड डेटा पे कोई मॉडल ट्रेन करती हूँ एंड देन आई रिलीज माय ओन मॉडल दैट इज कॉल्ड एज फाइनेंस जीपीटी. so that is a task specific fine tuned model. So मैंने क्या किया, जो चैट जीपीटी था जनरल टास्क के लिए मैंने उसको फाइन ट्यून कर दिया. आई हैव गिवन लॉट ऑफ फाइनेंशियल डेटा. वो इट इज नॉट any data, it is just financial data that I'm giving, and then it is capable of answering all the finance related questions. Is this clear to everyone?
Yes, ma'am.
ठीक है. Now these are some pre-trained models in different fields. मतलब बहुत सारे models होते हैं. You don't again need to know everything, but then this image contains some computer vision pre-trained models like object detection. एक task हो गया, उसके लिए कौन सा model use होता है. So you can see that on the screen. These are state of the art deep learning models. Recommendation system के लिए क्या होता है, speech के लिए क्या होता है. So we use ResNet plus by LSTMs. LSTMs I'll teach you in RNN. Then NLP में क्या है, text classification हो गया, या sentiment analysis के लिए BERT is one such model. I'll teach you BERT also जब हम NLP discuss करेंगे. Then question answering के लिए there are specific models like Roberta use होता है, T5 use होता है. So again like different tasks के लिए there are some existing pre-trained models that exist and they are like fine-tuned for these specific tasks. अब I just wanted to introduce you to few structures जो pre-trained models already हैं. So one such model is AlexNet. तो ये simple सा structure है. तो AlexNet में क्या है? There are alternative layers of conv and pooling. ये बहुत पुराना architecture है. CNN की जो मैंने आपको AlexNet, LayNet, ResNet, EfficientNet सब names बताए थे. Just wanted to show you how the structure looks like. So this is how AlexNet looks like, and you can see this is the actual architecture, like जो initial dimensions है. So there are total 5 convolution layers in this model. So we start with, this is the image. We apply convolution with stride 4 and the filter size is 11 cross 11 and then we get this. फिर हम इसमें एक और बार convolution apply करते हैं 3 cross 3 and then we get this dimension of images. We have taken stride as true. फिर we do pooling. ये pooling वाला step है. So pooling हमने apply किया. ओके, पूलिंग है या I think हाँ pooling ही apply किया because the size is not reduced. Then we take a stride of 2 and then 3 cross 3 and we apply convolution operation. So convolution 1, convolution 2, convolution 3. फिर again we implement pooling. यहाँ पे भी I guess pooling implement किया है. And then finally convolution here. So like it has got which 5 convolution layers and some pooling layers. And once this is done, we have three fully connected layers. Initially, the first fully connected layer has 9216 neurons. The second fully connected layer has 4096 neurons, and the third again has 4096. And then finally, the softmax activation function, and it is trained on image net data. So it is a very powerful architecture. It trained during an ImageNet कंपटीशन एक कंपटीशन हुआ था कोडिंग का दैट वाज कॉल्ड एज इमेजनेट एंड वहां पे देयर वाज अ मैन कॉल्ड एज एलेक्स जिसने ये आर्किटेक्चर बनाया तो he created this architecture and he named it as AlexNet and he won that competition as well. So ImageNet जो data है that it's a very huge data set that is trained on I think millions की कुछ images हैं जिसपे वो बहुत सारी images को collect करके label किया गया है. I'll just redefine. This is conv one layer. This is pooling का layer because यहाँ पे size half हुआ है. Just missed it. Then ये है conv two size same है. ये है pooling two layer. Then we have conv three. यहाँ पे dimension same है. We have con 4 again dimension same है we have con 5 yeah अभी 5 हुआ and then this is again pooling so pooling के 3 layers and conv के 5 layers and then the fully connected layers so this is how this architecture AlexNet is ये use नहीं होता now we have many complicated architectures so उस time पे this architecture performed really well second is VGG or net so VGG में you'll hear about VGG 16 VGG 16 जो है it is called as 16 because overall it has 16 layers. So this is जिससे AlexNet बना फिर और Kaggle के competitions हुए. So what people did was they came up with more architectures. So ये भी ImageNet का challenge में develop हुआ था. And it is specifically called as 16 because it contains total 16 layers. So इस model में total 16 layers है. So there is like this conf layer, then pooling layer है, फिर conv layer है. This is the pooling layer. Then again conv layer, pooling layer. So these are the dimensions how uh, and then they've implemented max pooling. Then finally, three fully connected layers is what they have again. So this is another such architecture. There are more complicated architecture. ये जो मैंने बताया, this is 2013 or 14 something का architecture है. Right now we are in 2026, so you can imagine how more complicated architectures we would be having. So again, any architecture that you want to study, आप Google पे जाओगे, you will get that image, you'll find a blog and you can read it. And this is important. How do we implement transfer learning and fine tuning in terms of, let's say if I'm working on a problem, how do we do this? तो मेरे पास एक बहुत बड़ा डेटा सेट है उस पे मैंने मॉडल ट्रेन किया एंड देन आई गेट सम आउटपुट what I'm going to do is I'm going to use the same model for my task. I may have a small data set. I'm going to use the same model for my task. Since I'm using the same model, I this part is called as transfer learning. I'm transferring the learning of this model for my own task. I'll get all these pre-trained weights and I'll freeze these layers. I'm going to freeze these layers. Then I'll add in more layers. I'll introduce final layers. हमेशा final layers हम लोग अपने task के हिसाब से introduce करते हैं. I'll show you this in code as well. And once I do that, I fine tune my model on these layers and I kind of I can unfreeze some freeze layers as well and then I can backpropagate weight new values, and then I can get my output. So this portion is called as fine tuning. There is an interview question, that is what is the difference between transfer learning and fine tuning, because बहुत लोगों को इन terms में confusion रहता है. So make sure you read about it later. Is everything clear till here? Let's do one thing. Uh, तो यहाँ तक सबको समझ आया? Okay. I have a coding
Yes.
notebook. मैं आपको एक बार ये दिखा देती हूँ how is this thing implemented in terms of code. Okay, a well documented notebook is what I have. So let me share my screen. Can you see this notebook?
Yes, ma'am.
So अब अगेन लाइक CNN का मैं बार बार सेम कोड बताऊं सो डजंट मेक सेंस. अगर आपको कहीं पे कुछ स्पेसिफिक पोर्शन ऑफ कोड में डाउट होता है आप मुझसे पूछ लेना. यू कैन रन दिस एट योर own time and you can try experimenting. So what we are going to do is we are going to use VGG16 model, and I've imported some model, all the important libraries. Then I'm using this I'm loading this pre-trained model. मैंने VGG16 वाला मॉडल लोड किया. आई डोंट इंक्लूड दी टॉप लेयर. लास्ट लेयर मतलब मैंने टॉप लेयर स्किप किया है, मुझे नहीं चाहिए इनपुट लेयर. इनपुट शेप आई हैव डिफाइंड एंड वी आर freezing the model, so इसलिए मैं उसको trainable, there is a parameter called as trainable that this model has. I need to set it false. If I don't set it false, वो model freeze नहीं होगा. जब भी मैं model dot fit करूंगी ये पूरा model back propagate करेगा new values of weights को. So that is why if I want to freeze it, I need to set this as false. Once I've done this, as I told you, we add our own layers. So I added my own layer. So I added a flattened wala layer. I added dense layer, dropout layer, and then again a dense layer for binary classification. So I am working on some binary classification tasks, and I have added these layers of my own. I am saying create a model, and my input is this base model that is BGG16, and I've added more layers. These are my layers that I have set for output. Then I compile my model as I do, optimizer, loss, metrics, सब same चीज़ है. So what I'm going to do is I'm going to load a data set from TensorFlow. This data set basically has images of flowers. So you can visit this link, and it just has some flowers का photo. I'll skip this part. ये मैं आपको थोड़ी देर में बताऊंगी when I talk about data augmentation. Basically, I'm just creating an image data, training data by implementing data augmentation. Now what I'm going to do is here I'm just defining, I'm loading the training data in train generator, ये जो variable है उसमें. So it is simple. I just define my directory कहाँ पे मेरा data present है. What is my target size? I need to basically make sure all images are of the same size. Initially ये हो सकता है मेरे पास different size की images हो. So I always ensure कि जो मेरा image size है that is all images are of same size. So I just set it as 224 cross 224. I defined my batch size, and since this data has classes, so मैंने जो class mode है वो categorical set कर दिया, and then I mentioned that this is my training subset. I'll call model.fit on my training data. I am just running it for 2 epochs, and then um, this is the accuracy that I get. Now what I can also do is अभी this is like very high, very superficial. हमें 100% accuracy मिल रहा है, but usually doesn't happen. It is a very simple, I told you, flowers का data set, and VGG16 is a very good model. It is trained on millions of images का data. अगर मुझे fine tuning, this was the transfer learning part till here. Now if I want to implement fine tuning, what I'm going to do is I'm going to unfreeze my base model. मैंने उसको unfreeze किया. I kept some initial layers frozen. कुछ initial layers के लिए मैंने trainable false set किया. मान लो मेरे पास total 16 layers है, तो मैंने 15 लेयर्स जो हैं वो फ्रीज कर दिए। जो लास्ट लेयर है 16th लेयर, आई हैव काइंड ऑफ आई हैव unfreezed it. And then I am saying model.compile. I'm just compiling this model and then I'm going to call model.fit. Now when I call this model.fit, जो भी मेरी, since my base model is unfreezed and I have some unfreezed layers as well, whatever updates that happened during back propagation are also propagated to this model, VGG16 model का unfroze जो भी layers है उस पे, unfreeze layers पे. And then I can just evaluate, I can fit my model, then I can just evaluate it on my data set to see how good it is performing. We're just doing it on trained data, so it is giving 100% accuracy. I did not do the train test bit, but then this is how you implement transfer learning and fine tuning in terms of code. Is this clear to everyone?
मैम
Hmm.
मैम अगर हम सारी लेयर मतलब चला रहे तो मैं आपने बोला कि कुछ लेयर में फ्रीज कर दिए, बट जो हम फ्रीज ना करें तो
तो वो एक तरीके से स्क्रैच से ही हो गया ना ट्रेन करना, क्योंकि आप सारी लेयर्स ट्रेन कर रहे हो तो उतना ही टाइम लगेगा जितना बस ये है कि आपने वो कोड नहीं लिखा है, बिकॉज वो कोड ऑलरेडी उस इस बेस मॉडल में डिफाइंड है. इट्स
मैम तो
जस्ट,
आउटपुट में कुछ चेंज आएगा मैम? जैसे अभी आपने बताया कि 99 आ रहा है मतलब आउटपुट जो आ रहा है, तो उसके बाद कुछ चेंज आएगा?
हाँ, सी इफ यू डू द फुल ट्रेनिंग ऑफ द मॉडल ऑब्वियसली चेंज होगा आउटपुट में. सो इस टास्क के लिए छोड़ दो, लाइक दिस इज अ वेरी सिंपल डेटा सेट आई टोल्ड यू फ्लावर का. इफ यू आर वर्किंग ऑन सम रियल टास्क, ठीक है, एंड you have two ways to deal with it. या तो आप स्क्रैच से मॉडल ट्रेन करो, so it can take time, it will take time mostly, and it will give you better results than fine tuning. आपने फाइन ट्यूनिंग इम्प्लीमेंट किया, तो उसने टाइम कम लिया, बट हो सकता है रिजल्ट टेस्टिंग डेटा पे उतना ज्यादा अच्छा ना हो, बट देन अगेन लाइक देयर आर डिफरेंट मेथड्स ऑफ फाइन ट्यूनिंग एज वेल.
ओके मैम.
ओके, बट अगेन अगर आप इसको ट्रू सेट कर दोगे ना, फ्रीज नहीं करोगे, सो इट इज जस्ट द सेम थिंग कि आप स्क्रैच से ही ट्रेन कर रहे हो पूरा मॉडल. ठीक है, देयर इज नो डिफरेंस टू इट. दिस इज द सेम थिंग written कि we transfer pre-trained model weights to a new model. um, this is weight transfer approach, and fine tuning में we just adjust pre-trained model weights. जैसे मैंने last layer को we freezed initial layers but we had some unfreeze layers as well. मैंने वहां पे मॉडल को फिट किया न्यू टास्क के लिए. दिस इज फाइन ट्यूनिंग. Now, we talk about fine tuning, pre-training, and all these stuff more around generative AI. So, it is an important topic from generative AI per se, because आजकल you'll see how you'll maybe if you read through some LinkedIn post or articles, you'll find out people mention, okay, this is fine-tuned for this specific task. तो हम हमारे पास जो भी ओपन सोर्स मॉडल्स है या फिर इनिशियल मॉडल्स है, हम उसको डिफरेंट डिफरेंट टास्क के लिए फाइन ट्यून कर रहे हैं. सो हेल्थ के लिए हेल्थ केयर डेटा पे, फाइनेंस के लिए फाइनेंस डेटा पे, लीगल प्रोसेसेस के लिए लीगल बेस्ड डेटा पे. सो मे बी यू कैन क्रिएट योर ओन जीपीटी फॉर वन सच टास्क जिसमें भी आपका इंटरेस्ट हो. नेक्स्ट टॉपिक इज इमेज ऑग्यूमेंटेशन. सो किसी को पता है ऑग्यूमेंटेशन टर्म का मतलब क्या होता है?
Increasing the size of data set.
Okay,
Are
it is a part of augmentation. So basically,
When mainly we make changes in the data set, like in the dimensions or in the orientation, colors,
correct,
or to
right,
increase the number of data set.
correct, right. So good. हो सकता है मेरे पास डेटा बहुत कम हो, ठीक है. अब अगर मैं कम डेटा पे मॉडल ट्रेन करूंगी तो वो उतना अच्छा रिजल्ट नहीं होगा. दूसरा, मुझे क्या चाहिए कि आई वांट अ जनरलाइज्ड मॉडल, so I can increase my data set by implementing image augmentation और data augmentation. इसमें हम करते क्या है, we apply transformation to images. Transformation can be anything. It can be rotation, It can be blurring, it can be brightening or darkening of the images, it can, like changing color, brightness patterns, uh, using grayscale images, anything. So, or zooming in, zooming out. So there are different kinds of augmentation techniques that we use. तो इससे दो चीजें होती हैं, एक तो अगर मेरा डेटा सेट बहुत छोटा है, I can increase the size of my data set by adding more images, some sort of like cropped images add कर दिया मैंने. तो अगर ये जो cat का image है, let's say I have only यहाँ तक image, then also it is a cat and it should be able to recognize it, so we can crop as well. So we adopt some different kinds of techniques, different augmentation techniques to uh, make sure we have a larger data set, and then we make a generalized model. So if the cat is turned upside down, it is still a cat. It is not that it is not a cat. तो अगर मान लो अपने डेटा सेट में सिर्फ ऐसे ही इमेजेस दिए कैट के, एंड आपने टेस्टिंग डेटा में ऐसा इमेज दिया, तो वो उसको कैट रिकॉग्नाइज ही नहीं करेगा. एंड दिस हैपेंस, वो मेमोराइज कर लेता है दैट any animal such with this sort of feature is a cat. So and in fact this happened as well. There are some case studies around it initially, तो आप पढ़ सकते हो. So what are different augmentation techniques? So rotation is one such technique. कैसे करते हैं? जो image data generator वाली line है that I showed you before, उसी में we just set rotation range as 30. So what it will do is it will rotate image by 30 degrees. So I can rotate by 90 degrees, 180 degrees, 270 degrees. It is that simple. So we can implement rotation, we can implement zoom in, zoom out. So zoom range हम दे सकते हैं. If I give 0.2, it will either zoom in or zoom out. इस केस में इसने zoom out किया है 20%. So it enlarges or shrinks the images while it just maintains the aspect ratio same. So we can recognize images of different sizes. So flipping हो गया, we can do horizontal flip, vertical flip. Same piece of code, just the different parameters is what it takes. So we can set it as true, so it will flip the images. So बहुत सारे techniques होते हैं, like there were more mentioned here. Color adjustments is also what we can do. So saturation levels, brightness, contrast, all these things can be done in data augmentation. So for that also, I have a small snippet of code that I can show. So this is where we are importing necessary libraries. MNIST वाला data set में use कर रही हूँ. I have just reshaped the images by 255, just basically normalizing the data set and reshaping all the images to 28 cross 28. Then I define this image data generator. It takes in all these parameters. I'm rotating images by 30 degrees. I am shifting it horizontally by 20%. I am shifting vertically by 20%. I'm adding some shear. Shear पता है क्या होता है? Do you know what shear is? If you
वेल
um,
मेनली जो फटने लगती है इमेज, ब्लर होने लगती है.
नहीं shear ये होता है. Let me show it to you. So this is shearing. मतलब ये original position ऐसा था, and then I pull it with some angle. So if I do it in y direction, तो it will be something like this. If sorry x direction अगर मैंने किया तो ये ऐसे खींच दिया, let's say. अगर मैंने y direction में pull किया तो ये ऐसे हो जाएगा. So this is called as shearing. If I pulled it from this corner, यहाँ से pull किया, then it will go under some this kind of transformation. So this is the shear transformation. This is also done. Here it is. ये समझ आ गया? So
यस.
this is all like done mathematically, ठीक है? So again इसके functions होते हैं, आप देख सकते हो. So shear transformation मैंने 20% apply किया, then zoom in या zoom out, and then I want to fill in if there are any missing pixels. अगर data में कुछ missing pixels है, I just want to fill it with the nearest same pixels. Then I just select an image. And what I'm going to do is I'm just going to show you how the augmented data looks like. So these are the augmentation types that I've applied. And I'm just going to do it for one image. So this is an image. 2 का, and then these are the transformations. So rotated में कैसा है, width shift, height shift, sheared image कैसा है, zoomed. So you can observe it. This is how it looks like. So again, you can try in more and more images, try plotting them out and see how these transformations affect the data. So this is how you can increase the size of the data as well. Okay, this is another concept. Is everyone clear with data augmentation wala part? Okay. So this is all done. Next two last concepts is dropout and batch normalization. तो ड्रॉप आउट हम क्यों करते हैं? We want to build a generalized model. Okay, since we want to build a generalized model, I don't want my model to memorize patterns. So what I do is during the training process, I turn off some neurons. So this prevents the model from memorizing the training data, and it prevents overfitting. So dropout is an important phenomena. Deep learning में सबसे बड़ा problem जो होता है, that is of overfitting. Deep learning performs well, but then हम उसको we build such complicated architecture, so training data पे तो बहुत अच्छा perform करता है, but testing data पे at times it doesn't performs well. So we need to take care of the augmentation part. We need to sorry take care of these overfitting वाला part. So we implement dropout, and same चीज के लिए we implement batch normalization. So there is one problem that happens, that is internal covariate shift. अब ये क्या होता है? जब भी हम CNN नेटवर्क्स बिल्ड कर रहे होते हैं एंड हम इस CNN नेटवर्क में what we try to do is all these activation functions that you have. So activation functions का जो value होता है, they start shifting towards either a very larger value or either very lower value. So this happens because we apply so many transformations. So जो मेरा data distribution होता है, if let's say my initial data distribution was something like this, ठीक है, and when I train it layer by layer, तो मेरा data का जो distribution होता है, maybe it shifts somewhat here, but then it can cause trouble. So what I want to do is मेरा जो input data का distribution है, it should remain the same. So let's say if my data distribution is following a bell curve, it should still follow a bell curve. There should be no skewness introduced. So in order to prevent any data distribution changes, हम करते क्या है? After every hidden layer, we implement normalization. After every transformation, like एक hidden layer है, मैंने hidden layer के बाद, there are two parts. We apply F वाला part and then we apply activation function. We get a final output. So after I do this, I normalize all the outputs. So this prevents internal covariate shift जो CNN के केस में होता है. It speeds up training, helps in optimization as well. It is a kind of regularization technique, and it ensures that there is no data distribution shift that happens. So batch normalization is also which you'll observe. Like कई बार आप code में देखोगे that this layer is added. This is the piece of code to implement batch normalization. बस हम इसका एक layer add कर देते हैं. So in any good coding implementation notebook में आपको ये batch normalization दिखाई देगा. Because that is why I just thought of covering it as a concept यहाँ पे. Um, is this clear to everyone? यहाँ तक?
मैम ये थोड़ा सा कॉन्सेप्ट एक बार और बता दें।
ठीक है, बैच नॉर्मलाइजेशन बेसिकली क्या होता है? देखो, एक तो हम डेटा नॉर्मलाइजेशन करते हैं डेटा प्री प्रोसेसिंग के टाइम पे, राइट? है ना? वी इम्प्लीमेंट नॉर्मलाइजेशन टेक्निक,
यस मैम।
राइट? सो इट्स द सेम थिंग, वी डू नॉर्मलाइजेशन, फॉर्मूला चेंज होता है मैथमेटिकली, इसलिए मैंने कवर नहीं किया है. व्हाट वी डू, व्हाट हैपेंस इज, जब हम डीप लर्निंग न्यूरल नेटवर्क्स ट्रेन कर रहे होते हैं, सो देयर इज अ फिनोमेना कॉल्ड एज इंटरनल कोवेरिएट शिफ्ट जो अगर होता है. इसमें होता क्या है कि जो मेरे एक्टिवेशन फंक्शंस के वैल्यूज होते हैं वो शिफ्ट होने लगते हैं. There is certain shift that happens in these activation function values, and we don't want it to happen such a way. We want it to remain stable during the whole training process. So this is it is a complicated phenomena. So you can just understand that it prevents internal covariate shift. Second is data distribution change होने लगता है when we train it layer by layers. So we want to make sure जो भी मेरा training data है उसका distribution change नहीं होना चाहिए over time. It should remain the same. So in order to address these problems, we implement batch normalization. What is batch normalization? Nothing. Just normalizing the outputs after every layer. हर लेयर के बाद जो भी मेरे पास यहाँ पे आउटपुट आ रहा होगा उनके टॉप पे मैं नॉर्मलाइजेशन का फॉर्मूला इम्प्लीमेंट करती हूँ. एंड देन आई गिव नॉर्मलाइज्ड डेटा टू द नेक्स्ट हिडन लेयर. उसका जो आउटपुट आया उसको मैंने नॉर्मलाइज किया. दैट इज व्हाट इज कॉल्ड एज बैच नॉर्मलाइजेशन. What are the benefits of using it? It helps, it speeds up the training process. Learning rate काफी improve हो जाता है. It helps us build optimized neural networks, and it also acts as a regularization technique. मतलब overfitting prevent करता है. So if you are implementing batch normalization, हो सकता है कि आपको drop out implement ना करना पड़े. ठीक है. So that is how it helps us. Is this clear now? Better?
यस मैम.
ठीक है. बाकी आप लोग पढ़ सकते हो उसके बारे में. बैच नॉर्मलाइजेशन क्या कॉन्सेप्ट. इट विल टेक सम टाइम. मैथमेटिकली इसलिए मैंने कवर नहीं किया. इट इज like the formula has more parameters than what you studied. Standardization और वो वाला चीज नहीं है same. So now what we'll do is I'll show you a project. ठीक है. So that I can actually tell you, like एक project है that it is a very big project. I did it before. It will take probably 24 hours for you to run. अगर आप Kaggle 24 hours या फिर अगर आप collab पे करते हो, so it will take some time. It has got lot of, there are training का images. So basically it is a skin cancer detection project. Skin cancer detection. So there are two kinds of cancers. It has got lot of images. Let me share. Good. See, these are the images. ये training में है for benign cancer and malignant cancer. There are two cases. एक होता है that can be cured, another is that cannot be cured. So you've got training data in train folder, testing data in the test folder. This is the data that I have, and then here is the notebook. So I'll tell you about the data set. Dataset has total 3600 images, and उन images का जो pixel resolution है that is 224 cross 224. Out of these 3600 images, 1800 images are of benign moles, and then 1800 are of malignant moles. There are two skin cancer types. One is like non-cancerous, so benign, which can be cured and they're not that harm. Malignant, they are cancerous skin growths and they can be life-threatening अगर हमने उसको early detection नहीं किया. So this is the data set that I have. I use Colab for training this model, and आपको क्या करना पड़ेगा, this ये folders upload करने पड़ेंगे drive पे. जो ये ट्रेन और टेस्ट वाले फोल्डर्स हैं उसको ड्राइव को माउंट करना पड़ेगा कोलैब में. लर्न अबाउट हाउ टू माउंट योर ड्राइव. इट्स ए सिंपल ऑप्शन आता है टू माउंट योर ड्राइव, एंड दिस इज द पीस ऑफ कोड दैट यू नीड टू रन simply. So you just run this, give access to your Google Drive, Google Colab पे, and then you need to give the path to your data set. So train and test data set का आपको पूरा path ऐसे define करना पड़ेगा. So you can get the path. You need to add it. So I'm going to do some important imports. I am going to, this is just piece of code to actually iterate through all of the images. So I'll just loop through each class folder. So there are two folders. Benign का folder अलग है, malignant का folder अलग है. तो मुझे सारा data collect करना है. And I'm going to randomly select some 16 images from the test set or the train set, and then this is how the images look like for the skin cancer. Now, here all the images by default are of 224 cross 224 data set का information में mentioned है, but usually real life में ऐसा नहीं होता, so we need to make sure that we actually resize the images. So resize करने के लिए we need to write some piece of code. It is, I think, written here. Yeah. So here the piece of code is written for resizing the images, image.resize, and I'm defining the size here. You can change the size from 224 cross 224 to 64 cross 64. So this quality or the size of the images will reduce. So this function here, it is defined for resizing the images and then saving the image as well. Here is some distribution key number of classes. Images कितने हैं per class. So benign class के कितने images है on my training data. So I've got some even distribution, like 1400 is for benign and some 1200 for malignant. थोड़ा सा difference है, but it is not very extreme. Same test data पे we have some similar kind of distribution. So I've got 350 images for benign skin cancer and 300 images for malignant. So this is just simple plots that we have plotted. Then this code is again for the output directory. So मुझे basically करना क्या, I need to process each file. कोई भी png, jpg, .jpeg, any file is there, I need to actually resize each and every image and I need to save that image. So मेरे पास what I'll do is I'll just create an output directory and उसमें मैं अपना resized image जो है वो save करूँगी, so that I have all the images that are of the same sizes. This is the best practice that you follow, and we save this to an output folder. And just to read, this is just simple piece of code to read all those files. So मुझे क्या करना पड़ेगा, input file path देना पड़ेगा. So I need to give the root folder and the file name. For giving the file names, I'm just looping, running a loop, because file का अगर आपने name देखा हो, it is in form of numbers. Let me show it to you. It is just numbers 1 2 3 से लेकर ऐसे कुछ numbers है. So this has got some 1800 3600 numbers होंगे. So that is why I'm running a for loop for it. And then output file path देना पड़ेगा to tell what I'm going to do is call this function. I'm going to give it input image and then I'm going to ask it to save to this output file path. So this is the piece of code. Next, what we do is, जब भी we are dealing with image data, we use this image data generator most of the time to apply any data, any image transformations. So here I'm rescaling all the images, and then I can implement any data augmentation also. Right now I'm just rescaling it by 255. Basically I'm normalizing my data set. That is what I'm doing. I'm not implementing any augmentation here as of now. So I do the same for training data set, I do the same for testing data set. I just normalize all my images. Then here I define the train generator. So I give my training directory. I've set the seed value as 777 so that again results are reproducible. Target size मेरा क्या है 224 cross 224. आप उसको again you can change the sizes. I've defined the batch size and this is a binary classification problem. Same thing I define it for the testing data. Is everything clear till here? Should I move ahead? Okay. Next I'm going to do is I'm going to implement transfer learning. So I have lot of models. I have defined a function. The best way when you write code in notebooks also is to define functions for each and every step, and then later on you can reuse those functions for, let's say, some different implementation notebook. So I have defined this function called as create model. So what I'm going to do is I'm going to use these existing models. That is why this notebook is like it takes a lot of time to run this whole piece of code. So you should do it on Colab or Kaggle Pay. Turn the GPU on and then do it. T4 and Kaggle पे P100 P4 कोई भी use कर सकते हो. You use these pre-trained models. So initially मैं क्या करूँगी, same I'll load this any initial model जो भी मेरा model होगा, I'll load that base model. I'll set the trainable as false. I am going to add in my own layers. So मैंने global average pooling add किया, then a dense layer with 1024 neurons. I implemented batch normalization. I implemented dropout. I added one more dense layer with 512 neurons. Again batch normalization, again dropout. And then I have this is my final output layer. This whole thing that you see here, if you notice बहुत ध्यान से, this is the layer name and then इसके बाद एक ये ऐसे लिखा हुआ है ब्रैकेट में x. So this is basically last layer का input here. तो जो भी last value है x का, this is basically that. So just define dense layer and then I just define the last layer. That's it. So this is one such way of writing, uh, defining model. Once I have done this, हम लोगों ने जो किया था वो एक list में किया था. This is also one way of defining layers. This is another way of defining. So I just write I just create this final model class जिसमें मैंने input output same तरीका है जो मैंने पिछला notebook दिखाया था उसके जैसा. And then I write model.compile. I am added Adam optimizer, binary cross entropy, and metrics as accuracy. I've created a list of models that I want to try, and these are so many models like Exception, ResNet, VGG16, Inception V3, DenseNet, MobileNet, MobileNet V2, EfficientNet, NASNet. So आप एक एक मॉडल देख सकते हो क्या है. Required नहीं, but just to show you how it looks like, I have added so many models. Next, what I'm going to do is I'll run a loop and I am going to save the best models. I'll be saving all the models. So save करने के लिए क्या है, जैसे Jupyter notebook अगर आप यूज करते हो तो जैसे आप कंट्रोल एस से पे क्लिक करते हो तो वो एक चेक पॉइंट क्रिएट करता है, राइट? हैव यू नोटिस्ड इट? इट जस्ट राइट्स लास्ट चेक पॉइंट. अभी ये लास्ट ईयर दिखा रहा है. सो इट्स एन ओल्ड नोटबुक, आई टोल्ड यू. If I just press control S now, it will just show me last checkpoint to now, right? So it creates checkpoints. अगर अब मुझे मैंने कुछ कोड में गड़बड़ किया and I want to revert back to my last implementation, I can just revert back to that last checkpoint. Similarly, जब हम models बनाते हैं तो हम models का भी checkpoint create कर सकते हैं using this model checkpoint function. I can just define model checkpoint and ask it to monitor validation accuracy. एंड जहां पे मेरा वैलिडेशन एक्यूरेसी सबसे हाई हो, मुझे सिर्फ वो वाला मॉडल सेव, उस मॉडल का वो वर्जन सेव करना है. तो लेट्स से मैं रेस्टनेट वाला मॉडल या VGG16 वाला मॉडल ट्रेन कर रही हूँ एंड एट एनी पॉइंट माय वैलिडेशन एक्यूरेसी वाज 90%, मैक्सिमम हाईएस्ट वही था, तो मैं उस वर्जन ऑफ मॉडल को सेव कर लूंगी. सो दिस इज व्हाट आई ट्राई टू डू. देन आई जस्ट कॉल model dot fit. Here I'm running a loop because मेरे पास multiple models हैं, so I need to call model.fit for every model. Then validation accuracy, I'm storing it in a list. I'll create a list, get the maximum validation accuracy, and I'm checking is my current validation accuracy better than the best validation accuracy. If yes, I'll just update my best validation accuracy and my model name as well, and I'll just kind of checkpoint it at that point. Once I have written whole this piece of code, I run it and then I these are some outputs that you get. So basically your results, जो भी यहाँ पे results आते हैं, you can just go through it. It is very huge. So we are doing it for how many epochs? Model dot fit 10 epochs के लिए करें. हम हर एक model 10 epochs के लिए train करें. So if I am to show you, पहला it starts with exception, training exception model, and ये epoch 1 का result है. validation accuracy improved from minus infinity to 77%. 77 से 81% गया. then 81 से improve नहीं हुआ, 81.851 से 81.81 हुआ. So this is how it keeps on improving for 10th epoch, and then it found out highest validation accuracy was 82%, and it will save that model. Then it went to the next model, ResNet wala model. It does this all, and then finally these are the results against all these models. So this is the most time consuming cell of your notebook, जो सबसे ज़्यादा time लेगा. Now the best model that you see here is the DenseNet 121 model with 86% का accuracy. This is the best model. Once I've figured out that this model is the best model, I am going to finalize this model and I'll train it for more number of epochs. So I just finalized this model. So here my base model, I've fixed it to DenseNet. And there is no loop. It is just the same thing. I've just finalized this model and I am going to I'm training it for 150 epochs. So now I'll do the final training for 150 epochs, and after 150 epochs, I get the accuracy of 91% on the training data set, but validation accuracy is 85% something. Uh, at some point, it has reached to 88% also. सो मे बी कहीं पे हुआ होगा 88 86% है यहाँ पे. At some point it reached 88%, so that is the maximum accuracy that we have achieved, which is higher than what we tested here with the 10 epochs. So 88% is the highest accuracy, validation accuracy that we achieve for this case. And then I can just plot out these results. So train accuracy versus validation accuracy ka plot is what is plotted here, and then the loss also. Since this accuracy is increasing, we are at a good stage. ये training data का accuracy हमेशा increase हो रहा है, which is bound to happen जितने ज़्यादा epochs के लिए. Validation accuracy, it follows somewhat this kind of curve. So maybe we can do some early stopping, implement some early stopping also. So, and then this is the loss curve. So, ये training data का loss है. So, loss is decreasing as we can see. And then validation accuracy का I think 80 के बाद से it is somewhat increasing. So, maybe we can like stop at somewhere between 40 to 80 की range में. कहीं पे we can figure out a midpoint, see where the highest accuracy we have achieved, and then we can train it for that number of epochs. This is how we have implemented transfer learning for this skin cancer detection data set that we had. Any doubts in this coding implementation notebook? किसी को कुछ questions आ रहे हो? Any concerns in your mind? Would some like were you able to understand this project? समझ आया सबको project? You can unmute and speak.
Yes, ma'am.
ठीक है. थोड़ा lengthy है project. आप लोग को मैं नोटबुक शेयर करूंगी. प्लीज एक बार देखो, रन करने का ट्राई करो. कुछ एरर आता है, नहीं समझ आ रहा है, प्लीज आस्क मी. दैट इज हाउ आई कैन हेल्प. पूरा प्रोजेक्ट लाइव तो रन कर नहीं सकती मैं, बिकॉज ये 24 आवर्स लेगा पूरा रन करने के लिए. बट अगेन लाइक इफ यू फेस सम एरर्स एंड इश्यूज, मैं वो हेल्प कर सकती हूँ. लाइक अभी आरएनएन्स वगैरह हम पढ़ेंगे, एनएलपी पढ़ेंगे, तो और बड़े प्रोजेक्ट्स होंगे, बड़ी नोटबुक्स होंगी. So I'll introduce concepts. जितना coding required होगा for you to learn those concepts, वो हम hands on करेंगे. बाकी mostly I'll try to walk you through the notebook and I'll give you the project files ताकि आप अपने own pace पे कर लो. ठीक है? Okay.
Yes, ma'am.
ठीक है. Again, like please take your time. देखना आराम से, नहीं समझ आया हो कुछ भी, please don't hesitate, पूछ लेना मुझसे. I'll answer on chats, या फिर एक मीटिंग रख लेंगे जिसमें मैं सिर्फ क्वेरीज आंसर करूंगी आप लोग के. ठीक है? So I can help you with that. But this is a very standard project, है ना? Like maybe if you participate in some hackathon या फिर कहीं पे you're doing some coding based project, you will be able to understand notebooks better जब आप पढ़ोगे Kaggle वगैरह पे, if you go through such notebooks. This concludes CNN का टॉपिक. कल का क्लास मॉर्निंग में रखूंगी मैं, चलेगा ना सबको? 12 11
मैम
12
कल तो
के अराउंड।
फ्राइडे, कल तो कॉलेज रहेगा।
अच्छा, कल कॉलेज रहेगा, परसों सैटरडे को।
यस मैम।
we'll start with RNNs next. ठीक है, RNNs wrap up करेंगे, then finally natural language processing. So RNNs is a
यस मैम।
tougher topic. पहले से disclaimer दे दिया है मैंने, थोड़ा कठिन है, but then it is important. I'll take 2 to 3 classes शायद RNN के लिए, and फिर हम natural language processing पे आएंगे. We'll try to build some chatbot उसमें, ठीक है, that you will find interesting.
यस मैम।
ठीक है, that's it for today's class. कुछ पूछना है, you guys can ask, otherwise we're good to end. Okay then, thank you, bye.